Thanks. Thank you very much. Thanks a lot for inviting me. And this is joint work with Susan Nathy at Stanford, and she's also at MSR as a visiting researcher, and Jano Pal, who is at the Central European University in Budapest, and he was a Microsoft intern 2 years ago, and he's going to be again a Microsoft intern this year. And so I just want to advertise the Microsoft internship is actually a very nice deal because it's 3 months, it's 10 to 12 weeks. People usually come in the summer, and usually you're supposed to work on a project. It can be, if you're an economist, it can become part of your thesis later. And so this is a project that Janne, Susan, and I worked on while he started being an intern at Microsoft. And it's very well paid. It's these tech salaries, so it's sort of it's an attractive internship. Amongst economists, amongst CS people, I think it's better known. Amongst economists, I'm an economist. It's less known, but it's becoming more well known. And for example, our lab has for economists about 3 positions, 3 internships a year. Actually, no, I'm sorry, it's now 4. 1 for the field, and then also every permanent researcher usually has an internship. And then New York City lab also has economists and internships for economists. So it's an interesting deal. So I want to talk about actually most of what I want to talk about is how social media, Facebook and Twitter, have affected the way we consume news. Okay, and because I have this data set, at the end, I just have a little encore, which is like, I want to talk a few minutes about a topic which uses the same data, but it's about a slightly different angle. It's about the Google News shutdown in Spain. If you followed the news, that happened in December, and we just happen to have the data to look at the effect of this shutdown. So I want to talk mostly about social news, but then give you a little bit of an insight of what happened, what we see in our data. How this aggregator shutdown in Spain affected news consumption in Spain, okay? Because it was sort of an interesting natural experiment, and so I hope I can talk about this a little bit. Good. So do I have until 1 or 1:15?
Until 1.
1. Okay. Good. So what motivated us was the observation that social news consumption is becoming increasingly important. There isn't actually, we try to find data on this, and the Pew surveys, they did various studies over the years. First of all, social media, clearly most people these days have a social media profile, at least on Facebook, often also on Twitter. People often get news from social media by, with social news, we mean that there's a New York Times article which is shared amongst your friends, and you click on it, and then it takes you, and then you go to the New York Times. Okay. So direct navigation would be you go to NewYorkTimes.com, and then you click on an article in the New York Times, or you go to the business homepage and click on articles there. And social navigation would be that you enter the New York Times from Facebook or Twitter. Okay. Now, 27% of adults regularly reported in 2011 that they regularly get news from social media. During the primaries, 20% said they got regularly updates from Facebook, 5% from Twitter. That doesn't tell us, the volume really. It just, it could be that they regularly could mean that, once a month they click on a New York Times article in their Facebook profile, in their Facebook news feed. So there are some reports, like news sites reported in 2011 that on average they got 9% of traffic from social media. Again, this is from the Pew survey, but it's definitely an increase from earlier times, like 2009. Okay, so that's becoming increasingly important. And if you just look on the total evidence, we did sort of a little mini survey amongst Facebook users, and you can see the younger users definitely, many of them report that they get actually most of their news from Facebook. That they just click on news articles which are shared amongst their friends. Okay. Now, so why do we care? What what's different about social media, if news consumption originates from social media versus originating from direct navigation or from Google search or Google News or from some aggregator, I mean, why does it matter? Well, one concern here is that maybe because we now get more social news from social media, maybe we are interested, we read about different topics, okay? Because maybe the topics that are shared on social media maybe are trendy topics everybody talks about, okay? Or maybe these are topics which, because you want to signal to your friends that you're a smart guy, maybe you actually share topics of scientific interest, okay? So maybe these kinds of topics are being shared and we read more about science, okay? It could also be that, because people like to share opinion articles, maybe we read more Paul Krugman articles than previously because, those are predominantly shared on social media. So question is, what's the effect on topics? And then within topic, do we read, for example, more biased news, okay? Do we read more emotional news? Because maybe even controlling for the topic distribution, even within a topic, say, about global warming, maybe we're interested now, maybe the kind of articles that are shared on social media are more fact-based or less fact-based. Maybe they are more emotional or less emotional than what we would read when we directly navigate news, okay? Yeah? So, previously, when we directly navigate news, the newspaper editor is filtering the articles for us. That's what they put on their homepage. Or Google News does it for us if you use Google News Search or Bing News or whatever. And now our friends do it for us, right? And what kind of job do they do filtering it? That's going to determine what we're going to consume. Now, political bias here is a particular concern within a topic, because even if you read, for example, the same amount of news about Iraq or Afghanistan and so on, if, for example, the news that's being read is more biased, it's more conservative or more liberal, and the liberals read the stories that are shared by their liberal friends and vice versa, that might have effect on society, on us becoming even more polarized than we already are. Okay. Now, there's one issue which I'm going to sidestep because we're still working on that data, which is the question about production and consumption. So I'm going to look basically at, mostly I'm going to look at users and what they consume when they directly navigate and when they look at social news, okay? But underlying that, there's this question about production and consumption. So on the first step, first of all, like social news has to be produced. There are users who have to share social news, right? And then conditional on that supply of news, I have to click on it, right? And that intersection of supply and demand, if you're an economist, you know these two curves, that determines what I finally see in terms of the volume of articles of each type that are being consumed, the number of clicks, okay? Now, that's a little bit of a challenge. Fortunately, there is one way around this, which is Facebook is difficult because Facebook doesn't generally share this data, and we don't really, we actually do have, Microsoft has some access to Facebook data, but we are not allowed to use it for this project. But Microsoft also has access to the Twitter Firehose. The Twitter Firehose basically gives you access to all the tweets. And a nice feature of Twitter so far is that the tweets are only chronologically ordered. They don't apply something like, previously Facebook used EdgeRank, and now they use other algorithms to basically prioritize your news feed. But Twitter doesn't use that, okay? And because of that, you basically, at any point in time you log into Twitter, you basically see exactly what people post, okay? So that makes it a little bit easier because, that Facebook angle basically adds another difficulty, which is production, filtering, and then consumption, right? So if you look at Twitter, you can take out that middle problem, and you can look separately at production of social news and consumption, what people click, okay? Of course, Twitter is much less popular than Facebook, but still we have like millions of users, and so it's doable, okay? All right, now, okay. So let me just get into the data description what we're using here. So the Twitter, okay. So our main data set is browsing data. And what I'm going to show you today is from a sample, for an 8-week sample we got in April and May 2013. But now we're actually redoing this analysis with a full sample, which we started in August 2014, and which is still ongoing. So that's going to be a much bigger sample. And the data we are getting is data from toolbar users. So these are Internet Explorer users who have Bing Bar installed. Okay, and there are like about 40 million people or so in the world who have that. Many million in the US. And one nice thing about Bing Bar is that when you have it installed, they ask you can opt out of that is if you want to collect, if you want to, for research purposes, collect browsing histories and search histories. And this is the data we are using here. Okay. And so the data we have essentially is an anonymous, it's a numeric ID for a user. So we can follow that user over days. That ID only changes if the user clears the cookies, okay? And for that user, we have basically the page loads, okay? All the URLs that are being loaded, and the referrer URL. The referrer URL is whenever you click on a URL, the browser also records where it came from, right? So for example, if you click New York Times, if you go to NewYorkTimes.com, and then you click an article on the New York Times homepage, then we'll record that as, that article is being loaded and you are referred from NewYorkTimes.com. Okay? And we should also see in the previous line that NewYorkTimes.com is actually a page load as well. Okay? Yeah, so we can create this linked list of page loads. We know the time when this happens, the exact time when the page is being loaded. And we know the dwell time. The dwell time is how long it takes. We also know the tab ID. So each tab in your browser has a different ID, so we know in which tab it's loaded. Okay. So this is a theory. In practice, all these programs have bugs, and if you work with these large data sets, you might have realized that there are often tons of bugs. And a lot of the time you spend is like programming around the idiosyncrasies of the problems in implementing this Bing Bar. Okay, and so this was also our job. Like often the referrer is missing, so then we have to infer it. Okay, also like increasingly websites, including Facebook and so on, instead of using a standard referral, they use Ajax, for example, or they use some fancy JavaScript to like go to the next page. Okay. And that creates all sorts of other problems. For example, if you click on Google News, then before you go to the actual article, you go to an intermediate page, which then sends you to the article. Okay, messes you completely up if you're not aware of that. Okay, Bing News doesn't do that. Other aggregators don't do that either. So you have to program around this idiosyncrasy. Facebook referrals are a complete mess because Facebook uses a lot of Ajax. Okay. But you can get around that, okay? There's a sort of technical appendix which is basically describing which is much longer than the actual paper, which is sort of describing the tricks you have to use in order to clean up that data to make it into something useful. All right, but in principle that's a very nice data set, and it's also like if you are, for example, a visiting researcher, or consulting researcher, or an intern at MSR, you can use that data. You get access to that very easily, and you can publish from it as well. Okay, so there's no publishing block on that, which is kind of very nice at MSR. Good. So we basically did this research, but we didn't have to ask anybody if we can publish that or not. Now, article data. So we not only so we discovered soon that basically just having the URLs isn't really sufficient. We also need to understand the content of the article, okay? Because it turns out when you just look at social media consumption and direct news consumption, you see that the types of articles that are being loaded are very different, okay? Social media consumption, for example, is much more heavy on, say, celebrity news, etc., okay? Has far fewer sports articles, right? So one way you can do it is you can just look at the URL, and that sometimes works. But doesn't always work consistently because, for example, publications like the Wall Street Journal, they have numeric URLs often. Okay, so you cannot infer from the URL from the form of the URL what kind of article it is. Okay. Besides, we wanted topics to be not just what we call super topics like sports or business. We actually wanted to drill down and understand this is about Syria, or this is about the IRS scandal, okay? Or this is about Benghazi, etc. Because understanding those topics is important, for example, if you understand political bias. If you think about Benghazi, this is something conservatives care about, okay? If you think about the shooting of Trayvon Martin, it was like a big news event back in 2013, that's something liberals care a lot about, gun control, okay? So understanding those topics is important to sort of understand, for example, if you want to know political bias. All right, so we needed article data. And what we used here for what I'm going to show you, we used the Bing search index. So, you know, search engines have to crawl the web and you know, get all the article data in order to build their index. And so we used that index. Okay, so we matched the URLs we had to that search index, and we extracted that. Okay. What we're actually doing for the rerun we are doing at the moment is we are doing something more sophisticated. We wrote our own scraper, which for the top 2,000 newspapers in the US just basically scrapes every day all the articles. Every 24 hours it runs and it scrapes all the articles. And it scrapes the articles in a sort of following way. What it does is it basically scrapes the home page and the main landing pages like business, you know, sports, etc., and then gets all the articles there. Okay? And the reason why we wrote the scraper is because we wrote it for two reasons. One is that because, you know, news consumption tends to have this long tail, okay, you actually miss many articles, many marginal articles, which only have a few page views. So if you only rely on the toolbar data, you know, you miss a lot of the sort of tail articles. Okay. And the second reason is that if you scrape your own article and actually you know the landing page structure of a newspaper, then you already know a lot about what types of articles these are. For example, you know, columnists, they all tend to be on a columnist webpage, okay? Right? Sports articles tend to be there, okay? So you almost get the super topics, as we call them, sports, business, columnists, opinion, etc. You get them for free, okay? And actually, the most valuable part of that is getting the columnists, getting the opinion articles for free, because identifying opinion articles is not trivial, okay? So we ran various classifiers, and you can do it, but it has a relatively high error rate, okay? Whereas if you get them from the landing page structure, you actually get them and they're very nice, okay? So it's you know, all you need to do is basically you do crowdsource a few hundred articles per newspaper. You find out which part of the landing page structure the columnists are, okay? And then you just, you know, get that, you know, you just code those as opinion articles, and it works really well, okay? Yep.
Like newspapers, are those print newspapers?
Everything, so it's including radio stations, if they have a news section. It includes even things like internetmoviedatabase.com/news, okay? Yeah, so what we did was you know, for these top 2,000, what we did is we looked at all the referrals from Google News and Bing News, okay? Plus, we looked at anything that's ever referred to from one of the top 50 aggregators, Reddit and other things. Then we got the URLs like NewYorkTimes.com or internetmoviedatabase.com/news, and we crowdsourced from each of those 10 random articles. And if the crowdsource workers told us this is news, then we included this in the 2,000 set. Okay, so it's so we think it's actually sort of the, you know, I mean, we spent a huge amount of time on, like, you know, getting this list, because we really wanted to sort of capture. We didn't want to just focus on the top 10 publications, so we wanted to capture as much as possible on news consumption. Yeah, and one of the, you know, one actually nice payoff is, like, for example, when I show you the Spanish news, you see, for example, as Google News is shutting down, people navigate away from, like, marginal newspapers towards the top newspapers. Direct navigation increases as Google News shuts down, but it increases mostly for the top 10. So you see this shift. So if you would only, you know, if you would only focus on the top 10 newspapers, you wouldn't see this substitution, for example. Okay. Besides, it's also the case that, you know, in order to like capture about 90% of the page views, you really have to get at least 300 publications right. If you just focus on the top 10 in our sample, you get a big chunk. You get like 30, 40%, but you still miss most of it. Okay, so this is article data, and yeah, so I don't really have so much time. Okay, so the way we published the way we got these newspapers is there's a published list on Wikipedia of all national and local newspapers. We took all the referrals from aggregators and we cleaned that up, crowdsourced it, and we got 6,200. And for the scraping, because we want to scrape every 24 hours, we can do 2,000 a day, the top 2,000 a day. Okay. And if you're interested in this code, so this is a self-contained C# code. It's relatively easy to run on a server, and it doesn't have to be a very large server. I mean, I can share the GitHub repository with you if you're interested. You just have to email me, and I can share that with you. Yeah.
Articles written just in English worldwide?
Yeah, we're focusing on US news, except for the Spanish case where we focus exclusively on Spanish news. Okay.
How do you deal with apps? You know, like if you read directly from AP or, you know.
Yes, very, very good. So, so we could deal with it. So we don't basically, because apps are channeled through the app developers side, so we don't have access to it. There is Windows Explorer on Windows Phone, but that's sort of a pitiful sample. So so we focus on desktop. Okay. So this is basically Internet Explorer on the desktop, because the Bing bar is not available on mobile news. And that's a concern, especially for social news, because a lot of social now, about half of social is now happening on mobiles, and so we miss that. And unfortunately, there's no real way around this. Also because the Facebook consumption on mobile is yeah. Anyway, we unfortunately don't see that. Okay. Let me tell you a little bit about how we classify articles. So you can get a lot of things like complexity of text, word count, sentence length, and so on. Readability scores. There are automatic automatic algorithms for that. We tried classifiers to get liberal and conservative bias, and that was very poor. Okay, so we're still trying things. And we are fortunate that above our floor there's this team that works on Cortana, this Microsoft assistant. Okay, and they are more sophisticated than we are, but they also said it's a hard problem. So getting political bias is hard. So for getting political bias, we use crowdsourcing. So we show people articles, and they tell us this is conservative or liberal. Okay, there's a problem with this approach, which is that this long tail. So even if you do, we did 10,000 articles, but that captures only a certain fraction of news views. Okay, so it would be nice if you could use these 10,000 articles as a training set, and then build a classifier to do political bias on all the rest. This is what we are working on, but I'm not holding my breath. I mean, we might have to just keep doing the crowdsourcing. Okay. Now. How do we classify the articles? Now, the method we use is we map articles to Wikipedia topics. And what I mean with a Wikipedia topic is all the big news events, Syrian war, Benghazi, IRS scandal, Trayvon Martin shooting, all these things, they have a Wikipedia article, which is relatively stable over time. And typically when there's a big news event, a few days or a week later, one of these articles appears. Okay? So so we wrote, actually, this is on Codeplex. If you're interested in that, it's called WikiPrep Sharp. It's based on a Perl project, which was written 6-7 years ago, but which no longer works. But it's basically a program that takes from the Wikimedia Foundation takes a dump of Wikimedia at any point in time, and basically extracts all the bigrams and words and topics and so on, and makes it easy to do data mining on it. Okay, so it's WikiPrep Sharp. You can find it on Codeplex, and you can use it. It requires quite a bit of memory, but it will run on any machine. And we use that to sort of process. We wrote it ourselves. We use that to process the Wikipedia data. Now, what we want to do is we basically want to map these articles into these Wikipedia articles. For example, if something is about the Benghazi embassy attack, we want to map that into the topic Benghazi on Wikipedia. Okay, and the way we do that is, first of all, we use just TF-IDF on the corpus of Wikipedia articles to construct basically a set of keywords. Okay, so what we then do is for each newspaper article, we extract, based on this method, we extract the 10 keywords and the top 20 bigrams. Okay, this works actually really well. So if you just have an article about Benghazi embassy attack, then the keywords you typically are going to get is Benghazi, Clinton, Secretary Clinton at the time. You see all these words, and also like the right bigrams. Okay, so if a human would look just at the top 10 keywords and the top 10, 20 bigrams, they would immediately know what the topic is about. Okay, I mean, if they know a little bit about news at the time. Now, what we do then is we use these top 10 keywords and bigrams. So these are the keywords, and these are the key bigrams. And each of them has a score of how good they are. And then what we say is, let's take every Wikipedia article there's out there, and let's do the same. Let's look at which keywords appear in there. For example, it might be this keyword, this. Okay, and it might be this bigram, this bigram, this bigram. And then we just take the sum of the scores here and divide by the total sum of the scores. Okay, so that's a number between 0 and 1, and the same here. And then we take a weighted average of those two. And if it's above a cutoff, we say this is a match. Okay, yeah. And this works extremely well. So we can map about 1/3 of all the articles right away to Wikipedia topics. Okay, we have to do some cleaning. So some Wikipedia topics are very similar. So we use the network of Wikipedia inlinks and outlinks to basically combine. We call them macro topics. For example, Benghazi has the Benghazi attack has like 2 or 3 subtopics. Okay, but when you look at the link structure between those Wikipedia articles, you can see that they're basically all the same thing. Right? So we use an algorithm to basically suggest those. And this is a topic of about 1,000 topics, which we then condense to about 150 topics. And we use the algorithm to suggest those clusters, and then we just use a poor research assistant to basically go through them and accept them or reject them. Okay, so it takes a day. It's not a big deal, but then we get sort of a nice set of kind of disjoint clusters. Okay, news topics. Now, so these are some of these topics. You see, there's death of Lee Rigby. This was an attack in London. Murder of Travis Alexander. Death and funeral of Margaret Thatcher. Where the biggest article is "Ding Dong, the witch is dead." Actually, we didn't know what this was, but until we did the topic analysis. This was some article in Guardian and Telegraph, I think. Various newspapers for some reason took this headline. So you wouldn't have recognized it from the headline. You would have thought this is about a movie or Wizard of Oz until you looked at the topics. This is 1/3 of articles. We can get another 1/3 of articles by basically constructing a network of articles in the following way. So we have these articles. So these are the articles. And we know that some of these articles belong to those clusters we just defined, right? And then the rest of the articles, we basically use an algorithm which is used in Bing News and news clustering in general. We just construct, based on the similarity in words and the similarity in topics, Wikipedia topics that are suggested, we construct a semantic and word similarity network. And then we just use modularity clustering to basically augment these initial clusters, okay, and get sort of other articles which really belong to the same cluster but which we missed, okay. And when we do this, we get we can classify a second third of articles, okay. So there is still a 1/3 of articles of the total corpus of articles we can't classify this way, but 2/3 we can, okay. Right. Okay. Now, once we have the articles, and once we have the topics, we know quite a bit. We know whether this is, we know for each article, except for that 1/3, we know if this article belongs to death of Lee Rigby, murder of Travis Alexander, shooting of Trayvon Martin, and so on. And then we ask two things. On the one hand, for each of these topics, shooting of Trayvon Martin and so on, we ask a bunch of questions from Amazon Turk workers, okay? We ask them, is this about sports, about business, is this about terrorism, etc.? Is this a potentially biased topic, politically biased topic? And also for each article within each topic, we take 20 articles, weighted by page views, and we do the same kind of crowdsourcing. But we ask all these questions on the article level, okay? So again, if you want, so this is another open source project. It's called crowdsourcer.org, and it's kind of very nice actually. So what it is you just construct an XML file, and this XML file has the list of tasks that you want the crowd workers to do, and then this is a platform which is it's a Python program, and it runs on your own server, and it basically does everything for you. It does like double data entry, it does payment to Amazon workers, so it interacts with the Amazon API and so on. So all we need to do is just provide XML files for the tasks, okay? And then everything else is done by this platform. Also open source. So if you want access to, well, it's actually, it's there. You just look for Crowdsourcer, and you can use that. But we found it useful, and other people at MSR are using it because, we tended to all write our own little solution. And I'm sure there are other solutions out there, so we wrote at MSR our own little solution ourselves, but, so what we have here is then, so we have topics and article classifications. And also, like for each article, we have political bias. So we ask a question on a scale from 0 to 10, how conservative or liberal it is, where 5 is unbiased, okay? Okay. Now, the article questions, we ask many questions there. We ask, who is it targeted at? What's the target audience? We ask, is this an in-depth article? Is this an article which is giving background research? We ask emotional questions. Is this a critical article, a positive article? Okay. Is this something that intends to, I mean, a lot of these questions are quite similar. Like, for example, this is a shocking article. And also, like, what did people intend, provided that they would share it? What do you think you would signal with this sharing? Okay. So the way the Mechanical Turk was relatively expensive for us because we discovered that especially for the political bias questions, there's a lot of disagreement. Okay. So what we did is we did triple data entry. Okay. And we basically try to take sort of the majority of 2 judges, to basically solve that. What we actually discovered is that there's big heterogeneity in the quality of judges. If you have done Amazon Turk research, maybe you've seen that yourself. So we have a refinement, that's the one we're going to use, which is basically the one where we construct for each judge a quality index, okay, of how good they are. And we measure that by, we kind of randomize articles and topics to all the judges. So basically, how much you agree on average with the other judges is a relatively good measure of how good you are. Okay? And so we use that then to break ties. And that turns out to be actually important because often you have, like, for one question where like there are 4 answers, you find that there are 3, quite often the case that you have 3 different answers. Okay? So in this case, we take the answer of the better judge. So
how many articles does each user typically rate?
It's about, I think it's about 200.
Why not use topics that you have rated yourself, and that could be used to evaluate the rater? So you could see agreement to something that you know what the classification is supposed to be, rate them in
Yes.
this way and then use kind of
Right.
to find a reliability measure for each one.
Yes, yes, yes. That's a good point.
It's just
Yeah. So actually, that's a very good suggestion. We haven't thought of that. So we thought about various ways of like cross-referencing with other judges, but that's something we
If you
should.
do 200, you probably could
Right.
send them 10 that are, what they are supposed to be with different kinds of.
And then we have sort of a
and then
benchmark.
You get a rating for each judge, and then you can
Yes.
assign weights even when we are
Right.
settling disputes.
That's a great suggestion. I mean, especially because we have to rerun the crowdsourcing again for the newest data sample. Okay, so let me tell you now about the data, about the results. I say here mini sessions origins. What do we mean with that? So if you go back to the URL stream we are getting from the browsing data, basically one way you can think about this is you can think about a browsing session. A browsing session might go on over say an hour. Okay. And what people do is when they browse news, they typically do something like the following. They look up the lottery. Okay? Lottery is very common. After they looked up the lottery, they do some Facebook. Then from Facebook, they might go to a New York Times article. From the New York Times article, they read this for a while. Then they go back to Facebook. Or they go back to their banking site. Okay? They do some of that. They shop on Amazon. Quarter of the time spent on that. And then they go back and they read something else on the local newspaper. Okay. So basically, one way to think about this is we think about these as mini news sessions. Okay. So this is basically like each of these has an entry point. Either it's Facebook, or it's a direct navigation, or it's a search. Okay. And then within that mini session, after you are in that newspaper, then you look around a little bit, then you stop, you do something else. And then you start again, okay? So the way we do this is we see this stream here, and we use backward induction, we start from here, and we basically construct these news mini sessions by looking at the last news page view and look at the linked list of things, okay? Sometimes this linked list is like a tree because I might be at a landing page here and then go here, for example, right? Once we have something where we cannot go on, once we found the root, we stop there, we take this out, and we repeat the algorithm, okay? In this way, we construct what we call these news mini sessions, okay? Yeah? If you construct these news mini sessions, you can look at the entry point, and then you can see, okay, what's this entry point? Is it search? Does it come from a Google search, usually, or Bing search, or whatever? Does it come from an email? It's also common. Is it direct navigation? And there you have to be careful because actually the most common way to go to NewYorkTimes.com is to search for New York Times in the browser and then go to NewYorkTimes.com. So you shouldn't make the mistake of classifying that as search, okay? That's direct navigation. Web portals are quite common. So when you do this and we classify this, we find that about 7.5% of sessions come from social, okay? Yeah? So this is how the session starts. Then on average, once you're in the sessions, you have about 2 or 3 page views, okay? Yeah. So we think it only makes sense to think about social in terms of like the entry into a mini news session, okay? Because what you do subsequently, it's not clear how you should classify that, because it wasn't it started off as search, but then you continue doing something else. So this looks lower than what we see from the Pew Research, okay? Which is probably not surprising because Internet Explorer users tend to be a little bit older, okay? Have a little bit, and age is an important predictor here, okay? So I don't want to say, you shouldn't take these numbers as sort of what you expect from the universe of all Internet users, okay? This is a particular sample of Internet Explorer users with Bing bar. And the same is true for the Spanish news data. Now, if you look at referrals from social media, then you see that some of them have a really large referral share, like the Blaze, conservative. They have a very large share. New York Times also has a large share. Huffington Post is also relatively large. Okay. Okay. So now let's look at what we call super topics. So super topics is So it's a little bit confusing, but just bear with me. There are topics. So these are things like death of Lee Rigby, okay? These are Wikipedia topics. Then there are macro topics. Macro topics are groups of Wikipedia topics which are really the same. Okay? Again, death of Lee Rigby might be 3 or 4 Wikipedia articles, okay? And then super topics is what you commonly see when you open a newspaper. There's a sports section, a business section, and so on, okay? Yeah? And, we have crime, politics, disaster, celebrities, business, science, tech, sports. And so you see here, the red thing is direct navigation, okay? So this is a share of news where people have directly navigated to the news, okay? Yeah? So you can see here, these are the share of news mini sessions that directly navigate. And you can see it's, there's a lot of crime, quite a bit of sports. Some disasters here. Some celebrities. Okay, so this is the distribution in super topics. Now, the blue thing is what we call the social media navigation. So this is a share of news sessions that start from social media. Okay, and when you can look at here, you can see that there's basically, they don't look hugely different. Okay, there are some differences. But actually, these differences, like for example, disasters seem to be less popular with social media, okay? More popular with direct navigation. But actually, these differences are mostly explained by user heterogeneity. What I mean with that is that think about the following: the people who, basically, they're people who use a lot of social media, okay? And the people who use a lot of social media, they might be the people, for example, who don't like disaster news very much, okay? But if you look at their direct navigation, you also see that they don't like disaster news very much, okay? Yeah? So this counterfactual is important for the following reason. Let's say that you are the Wall Street Journal editor. You see a shift from direct navigation to social media, okay? Now the question you're asking yourself is, should I shift reporters away from disaster to like something else, okay? Or should I move them more into sports or more into celebrities, okay? And, if it's all explained by user heterogeneity, then no, you shouldn't. Because basically, what's going to happen is that the users who already on the Wall Street Journal, for example, don't like disaster news, they shift to social media, but they also won't click on disaster news there, okay? So it's basically not having an effect on the total volume of news you see being consumed, okay? Yeah? So to the extent that you can explain shifts in news consumption by user heterogeneity, as a newspaper editor, you shouldn't care about it, okay? Is that clear? So what we do here is a counterfactual, and the counterfactual is doing the following. We basically look at the users who have, most users have direct and social media navigation, okay? Then what we do is for each social media view we assume that they browse social media, they browse the topics in the same proportions as they browse direct navigation, okay? And then we use that to basically construct a predicted distribution of topics, okay, for the social media browsers we have, okay? Now, if it's the case that the social media browsers are quite different, but if it's a case that basically people browse social news and direct news exactly the same way, okay? But people who browse social news have different preferences than people who don't browse social news, then basically this counterfactual should explain most of the thing, okay? And this is what you see here, for example. You can see that, once you do the counterfactual, you basically get back the social media share of this topic, okay? Which just means that the people who use social media a lot, also the people who don't like disaster news, okay? Now, what is interesting, what is important for the newspaper editors is that when you look at social media, you see a shift towards bigger outlets, and that's not explained by the user mix. And that's probably explained by the production of social news. New York Times is much more shared than your local newspaper. Okay.
So those numbers are quantiles?
Yes, these are like kind of in the ranking, in the page view ranking, how popular these various online newspaper outlets are. Okay, and yeah, and so you can see that you can see basically that the social media navigation is focused much more heavily on the big outlets. Okay, and that's not explained by the user mix. So basically what happens is if you shift like 20% of your, if you take any user, you shift 20% of his browsing to social media, he's on average going to browse bigger news outlets, okay? So it's not explained by the users going to bigger news outlets also using social media more, okay? Because otherwise this green thing would be up here, okay? Now, so there isn't so much action happening across topics. What about within topics? So within topics, we can use the crowdsourcing to actually look at, do people browse more emotional news, etc. Okay. So here, okay. So one thing here is you can see, for example, that on social media there's more individual perspective, okay, which is not explained by the counterfactual, okay. And that's sort of a pattern actually. And what I'm going to show you is that basically within topics, social media tends to like select articles which are more opinionated, okay, more emotional, and consequently also more from individual perspective, okay. Interestingly, they claim that social media has more in-depth analysis, but also much more controversial and one-sided, okay. And again, you can see this is only partially explained by the user composition, okay? So it's true that the people who like more one-sided news also use social media more, okay? But that doesn't fully explain the social media consumption of opinionated news, okay? So there's a shift towards more opinionated news. You can also see this here, more of them are opinion articles. Again, this is not explained by the user composition. More is politically controversial, and more is either caring, supportive, etc., but in one way or another biased or emotional, okay? Yeah? So just to summarize, not so many differences across topics, but within topics we see significant differences, not explained by the counterfactual. Yeah?
Would articles that blame someone be also
Yes. If you have, for example, if you say, for example, this is sort of typical, like if you look we looked at this, it's on the slides, but something like for example, Benghazi, conservatives blame Obama, for the Benghazi attack, or Secretary Clinton. So that's exactly what's in there.
Would you find the same kind of difference to direct navigation in that case as you found for caring and supportive, or
I think so. I mean, we haven't looked at that specifically.
okay.
But
so this is not these are the ones that you focused so far.
Well, this is across all the articles we have. Okay, so this will include Benghazi, but also all the other topics. Actually, I should say this is for the subset of topics where political bias is possible. Okay, so we excluded topics like 2013 NFL. Okay, because there's probably not so much political bias. Also, with the names of these teams, there are things here. Okay. Targeted at women, it's a little bit more here. Targeted parents of young children, also quite common. A lot of them are actually vaccine articles and things like that. Alternative medicine, yeah. Mm-hmm.
Do you see the converse for a lot of these then too? Like your methodology, then targeted women is more on social media than targeted at men, by definition need less, right?
Yes, that's true. That's true.
So all of that plays out when you look at
Right. So, again, it's interesting that the counterfactual doesn't really explain that, because one thing that could be the case is that, for example, women are more heavily engaged in social media sharing, okay? That could explain it, but then it would be explained by the counterfactual, okay? Because, women probably also read more articles which are targeted at women, so they share them more, but, that doesn't really explain this, okay? So, readers feel strong emotions. So interestingly, that's actually explained by the counterfactual. So the emotion things has difference, but it's not quite as strong as the previous slide. but broadly consistent. Okay, so let me tell you the political bias. So political bias is things like Blaze, NewYorkTimes.com. They have a large share of topics which are potentially politically biased. Okay, and clearly like Shine or movies, Yahoo.com, they don't. Okay, and you can see the bias here. So the way we define bias is from the crowdsourcing. Okay, so do you find a conservative or liberal users if they read mostly conservative or liberal articles based on our crowdsourcing? Okay, and similarly, we define outlets as conservative or liberal if they are above or below the median. In terms of politically biased, potentially biased articles being more liberal or more conservative. So let me just show you this graph here because I'm almost running out of time. So if you just look across potentially biased topics, you don't really find a big difference, not a huge difference. But what's interesting, if you look at only conservatives or only liberals, so only conservatives is, only conservatives, they clearly read more conservative news directly, right? So this is again direct navigation. So this is by construction. But then if you look at their social media news consumption, you can see it's even more biased. Okay? And this is significantly more biased. So this goes up from 40% to like 75%, okay? Plus, this is not explained by the user composition, okay? So it could be the case that the people who are particularly conservative, they read it, they do a lot of social media, okay? And then, it would just be the user composition generating that graph, but this is not the case. And same is for liberals. Liberals, by construction, read more liberal news, okay? But, they do it even more strongly when it comes to social media, okay?
How did you classify the people?
So we classified them according to their news consumption, news articles, when they were like potentially politically biased, if they read mostly conservative or mostly liberal news. We took the median of that,
Okay, so
and above or below the median.
So it really is by construction.
Yes. So the red one is by construction, okay, but not the blue one, okay. Now, okay. So this is this evidence for the filter bubble I mentioned, and evidence basically for this echo chamber effect. But I should caution that there's only, well, so let me just, so I just want to show you, these are like 4 slides, but I just want to show them to you because it's, this is from Spain. So let me just tell you a little bit, Spain, if you follow the news, Spain Spain passed a law which basically in 2014 said that from January this year onwards, news aggregators have to pay for every snippet that's displayed. Okay, they changed copyright law. Okay, and if you as a Germany has a similar law, but in Germany basically a newspaper can say I'm not going to do that. Okay, I'm not going to charge Google for that. And Google actually continued offering Google News in Germany, but they said that if you don't give us this free usage, we're just going to take you out of the index. And basically all the big newspapers said, no, go on. And Spain wanted to be very smart, and so they basically passed this law that made it impossible. So you cannot opt out of this as a publisher because it's done by a central agency, okay, which collects the money. So even if you don't want to get paid, there's no way for you to avoid it. Okay? So what did Google do? They shut down on the 16th of December, they shut down Google News completely. No more there. If you go there, there's a page saying that we are very sorry. It's gone. Now, question is, did these users now browse less news? If they, Google News wasn't there anymore, what did they do? Okay, and who benefited? What types of outlets benefited and who suffered? So, if you look at, so one interesting thing actually, if you look at the data is, most navigation in Spain, at least in the Internet Explorer sample, is direct, and Google has a big share of it, but most of it comes from search and not from Google News. And to understand the difference is, if you search for Obama on the Google page, Google homepage, then there's always a news box, right, appearing. That is not illegal for that you're not charged. Google isn't charged. So Google continue to offer that. And actually most of news consumption from search comes from there. It's only a tiny bit that comes from the Google News homepage, okay? So you wouldn't expect that this law overall has any big effect, okay? Because so little of that is actually coming from news.google.es, okay? The same is true in the US. There's a huge share, 30% or so, coming from Google search, but it's coming from organic search and the news box there rather than from news.google.com, okay? So something to realize. But so what we do here is we construct two sets of users. Those who predominantly use Google News, who use Google News at least once a week, and those who don't, okay? And then we say the following. We basically take, for every Google News user, we sort of take a control user who doesn't use Google News, okay? But uses overall, his overall news consumption is similar to the Google News user, and also his overall usage of Internet Explorer is similar, okay? Yeah? So think about these two sides of the room. The left side are the people who occasionally use Google News. The right side, they don't use Google News, but both of you consume about the same amount of news and use a browser about the same amount, okay? So if you look at before, you can see that these two groups by construction are basically following very similar patterns, They go down on weekends. Internet Explorer is a work browser mostly, so they do these kinds of things. But what happens after the 16th? You can see that the Google News users, they have a slowdown for a little bit, but then actually they catch up again, okay? So it took them about 4 days to substitute away from Google News and do something else, okay? Now for these users, Google News was a big share of their browsing. It was about 25% or so of their browsing, okay? For this subset of users, okay? But it didn't take them so long, okay? But what did they do? Well, clearly, the Google News users after the 16th went down to 0. But they increased their direct navigation a lot, okay? So this red thing is direct navigation, and this is search. So they increased both search and direct navigation. They didn't do much with social, okay? So they substituted away, they used more Google search, but in particular, they used almost 20% more direct navigation, yeah? So this is actually what these newspapers wanted. They wanted to move away from Google search into the direct navigation, okay? It affected only a tiny share of users, but if you look at the non-Google News users, you don't see any of these patterns, okay? This spike here, by the way, is when the Crown Princess was potentially indicted for something. Everything went crazy on that day. Now what happens to the top 5 outlets? For the Google News users, you can see that basically the top 5 and the top 20 consumption went up. So when they substituted away to Google News, from Google News to direct navigation, they focused mostly on the main publishers. Nothing happened for the guys who don't use Google News, okay? So you can see who benefited were the big guys. And these were exactly the ones who were pushing this law. The guys who were objecting to it were the smaller publishers. They are the ones who suffered. So basically, did Google News users browse less news? No. Did they substitute? Yes. They substituted direct navigation. And who benefited? The large guys benefited, okay? And probably if you do a model of consumer welfare, probably the Google News users suffered somewhat, because their variety went down. Yeah? So this is something we haven't really looked at, but it sort of suggests itself that. But for that, you would need a structural model to estimate that. Okay. So I'm running out of time essentially. So thank you very much.